Okay, computer languages. So we want to program and we have to use a computer language. But the kind of language we're going to use is called here a high-level language. Basically, there are other languages, we say assembly language and machine language. Those are not the kind of programming most people learn how to do. People learn high-level languages like Visual Basic.net or Java or Python or other languages like that. But those are called high-level languages. So we have other other sort of computer languages. So machine languages, languages that the computer can directly understand. So each operation is a string of digits, just ones and zeros. So actually, at the very base level, that's all a computer can understand, is ones and zeros. And why is that? Because the computer is basically a whole billions and billions of switches that can be either off or on. And so like off might be 1, we might want to turn a switch off and we'll send a 1 to indicate that, or we might want to turn a switch on or maybe that's 0 or vice versa. But anyway, so basically they're all switches. So if you really want to do programming at the very basic level, you just have to say what to do with all those billions of switches. And you do that by sending a bunch of ones and zeros. So that sounds crazy, but that's called machine language. And machine languages are dependent on the machine that you're using. So you might write a program in machine language for one computer, like on a Windows computer, but it wouldn't make any sense on a Mac computer or a Linux computer. And also, obviously, it's difficult for humans to freely use because it's zeros and ones. It's very hard to read a program that consists of zeros and ones. Okay, the next level of computer language is kind of easier for us to read would be called assembly languages. So more English-like, uses words from natural language. Instead of zeros and ones, maybe it uses some words. Each an abbreviation for a single machine language operation, translated to machine language by special programs called assemblers. So you write something in assembly language, and then that is translated into machine language, because machine language is the only thing that the computer can really understand. So that's translated to machine language by a special program called an assembler. Still, it's not convenient for humans, because it uses some words from natural language, but basically it's very, again, difficult to read. And then we have high-level languages. That's what we're going to learn. Visual Basic.net, or Java would be another example, or Python would be another example. So-called programming languages, single statements that can accomplish bigger tasks. So you don't have to explain to the computer what each circuit, all of the billions of circuits should do. You can write something like print this statement, and it will accomplish the printing. Whereas if you had to do that in machine language, you'd have to write some crazy string of zeros and ones, maybe 10,000 zeros and ones or something like that, to get it to print something. Okay, groups, single statements that can accomplish bigger tasks. Groups of a set of related basic operations, much more convenient for humans. So that's called high-level languages. So it's easier for us to read and also much easier for us to program. So we can imagine that originally people were doing programming only with this kind of language, and then they wrote assemblers so they could do it. They could write something a little bit more easily in assembly language, which would then get translated into machine language. And now we have high-level languages, which will basically, you run something here and it does, it runs a bunch of assembly language commands, and so it gets done at the machine language level as well. Okay.